try something else. Okay, we're going to do this. Okay. Obnoxious. Can you tell me what you're doing? By the way, that'd take you like an hour and a half. No. There's a lot going on there. Okay, you are kind of abducting and medially rotating, and then you are, oh God, it just goes on and on. Muscles are contracting and relaxing. So we have muscles pulling you out. These are relaxing, and then these start pulling, and these, oh, it goes on and on. But the important thing is, once again, going out and coming back is pretty much the opposite group of muscles doing similar things. Once again, going back to little kids. Ever watch a little kid when they learn to drink from a cup? There's a cup sitting there. They're just learning. Now, I give you a cup. I say, okay. I say, I'd like you to reach out and grab your bottle there and take a drink. You don't have to do it, but you can pretend, okay? Yeah. But the little kid reaches out, boom, and the cup goes flying. Have you ever seen that happen? Happens all, especially when they're first learning. Why? What's going on? Why can't they just reach out and grab that cup and take their drink? Instead, they go, ching! They go to pet the cat. Okay? You know, you go to pet the cat, you go, oh, nice. They come up there, why? What's going on? It's perfect. Believe me, your question is a very complicated question, which is why we're petting cats and knocking over water bottles. What's the difference between reaching out and grabbing that water bottle and reaching out and knocking it over? What?
You didn't stop.
You didn't stop, but let's say you stopped at the, so I go, ding, and I hit it and it goes flat. But I did stop. Control. It's all about control. This is control. This, hitting somebody, backhanding them. Same motion. Same motion. Different amount of control. In Parkinson's, to get back to the question, as you do this, what you don't realize is that this is a whole series of small motions. Ding, 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 that you have control over. In Parkinson's, you lose some of that control, so that instead of this, you get this. You get the trembling. You do little indistinct, or sometimes very distinct, movements to their extreme. So I do this, and it comes out as this, trembling. So we're going to look at that in pretty good detail, because the way the signaling path gets screwed up, the reality is in Parkinson's, you're losing neurotransmitter production. Initially, you lose production followed by death of cells. And we're going to look at we're going to look at 4 different pathways involved with 4 different neuro or motor issues that can look very similar, but they occur at different parts of your brain. So, yeah. All right, I want to leave the synapse. This was a review that we never did early in the semester, and I wish we had done it earlier. So, all right, plexes. Plexus, singular, plexes, plural. Plexes is the root that we see in complex. All right? So plexes are complex. Once again, I'm going to bring in some figures from another textbook and a couple of tables from another textbook that I think are just going to make your lives a little bit easier. When we hear the term branches, literally, that's a nerve. A branch coming off of a plexus is indeed a nerve. We're going to look at some of these complex structures within a plexus. We're going to look at functions. You know, why should we have this, and why, you know, getting our signal to a target becomes very important. And then we're going to take some time and tie this into movement. So, your textbook gives very short acknowledgement on the actual existence of the cervical plexus. I believe it's a very big paragraph on one page. Okay. What we are going to do is when I point out a particular nerve for you, what you're going to have to know are the roots. These ventral rami are what we call the nerve roots. We'll talk about that again. We'll revisit that in just a minute. And what are the targets? Now, within the cervical plexus, one very important nerve that I want you to know well is the phrenic nerve. Okay, here it is. The phrenic nerve has its roots in C3, C4, and C5. Fiber tracts from those three cervical spinal nerves combine to form the phrenic nerve. So here's the phrenic nerve. Here's C5 coming in, C4 coming in, C3 coming in. Are we okay with that idea? Now, the phrenic nerve innervates the diaphragm. Diaphragm sits right about here. Okay? Just if you can find the edges of your rib cage, that's more or less how the diaphragm sits. And it covers the whole of your, it divides your thoracic cavity from your abdominal cavity. So it starts or stops, however you want to look at it, at your spine, follows the edge of the ribs around, comes to the front. Your diaphragm, what's it good for? Breathing. As your diaphragm contracts, it flattens, so it goes down a little, descends a little bit, and you inhale. The innervation for the diaphragm is from the phrenic nerve. The innervation for your diaphragm is coming off of this area, right about here, okay, of your cervical spine. Huh, why is that important? Why not have the signals going to your diaphragm coming off? Do you have spinal nerves close to your diaphragm? Yeah. Why not have it come off there? It's a good question. Some of you might watch football. Okay? Or soccer, rugby. These are all contact sports. And on occasion, a player on the field gets hit in the upper back. Now, if the signal to the diaphragm was coming off the cord closer to the diaphragm, you get hit in the upper back, what could we do? We could have enough trauma to disrupt signaling to your diaphragm. In an evolutionary context, that's not good. On occasion, people will get hit in the back and lose some sensory function. They might have pain, but what can they still do? Breathe. As a matter of fact, unless you break your neck quite high, or actually break the cord, you can still breathe. You break your back, you can still breathe. Oh, well that's cool. And that has to do with the fact that these signals are coming out quite high. So you should know the phrenic nerve. You should know what they're calling in this the ventral rami, which are the nerve roots coming out. Are we okay with that? Cool. Now, your textbook starts with this gorgeous figure talking about nerve plexus. This, even looking at it in a living human or a cadaver, is a nightmare. You look at this, have you ever go to LA? Have you been to LA? Have you ever driven the roads in LA? Okay. That's what the freeways look like. Okay? If you look at the freeways from a helicopter, that's it. It allows you to get anywhere from anywhere else. Yeah. Oh my God. Every time I teach this, I look at that and I kind of shake my head. I go, okay, what are we going to do here? Roots, trunks, divisions, cords, and branches. Roots are these, once again, ventral rami, if we want to think about them that way. So C5 is the cervical spinal nerve root 5. Okay? C6, C7, C8. Okay, down to T1 here. These join together, or not, to form trunks. The upper trunk, the middle trunk, the lower trunk. Upper, middle, lower. We okay with that concept? So you got the 3 trunks. All right. We then have the divisions. The divisions will be anterior or posterior. Oh darn, beautifully. Posterior is purple, anterior is yellow. Anterior, posterior. Once again, not too bad. Here's where it gets a little bit weird. The cords. The lateral cord, the posterior cord, and the medial cord. Here they are, all right? This is a little more lateral. This is kind of in the posterior part because it's coming off the posterior division. And this is kind of maybe medial, but I don't have any good way for you to really know those immediately, other than following them through. Don't worry, you're going to be responsible for kind of understanding this, but we're going to go through 5 nerves that I really want you to know. And then you'll see branches. All of these are branches. Branches are what we would call a nerve. The musculocutaneous nerve, the axillary nerve, the median nerve, those are all the nerves coming off. Now, I want to take you to some other figures, one of which is quite nice. So this is showing, once again, the whole thing, different colors, but all the little pieces are color-coded in here, okay? And this shows you how they get down to your arm. Because the reality is, your brachial plexus provides the innervations for your upper chest, shoulder, and everything in your arm. 5 nerves: the musculocutaneous, the median, the ulnar, the radial, and the axillary. I'll post these slides after, maybe in the morning. Yeah, I want to post them tonight, but it's going to be 7:30 by the time I get home. And just like you, I'm really not going to want to think about this. But I will get them posted. All right. So the musculocutaneous nerve comes off the lateral cord, which comes off the anterior division, which comes off the upper and middle trunk, which takes us all the way back to C5, 6, and 7. The median nerve